Welcome back, and this is the new tutorial on econometrics, simple linear regression model. And this is our simple linear regression model, and let know each of the variable, what is the name and what is our aim, what we'd like to explain this simple linear regression model. Let's first define what is x. X is our independent or regressor, and this is the independent variable and this is the dependent variable. And beta 0, these parameters known as intercept term, and this parameter beta 1 is called slope coefficient. Actually both are coefficient, or we sometimes call regression coefficient, beta 0 and beta 1. And this is our parameter, two parameter we called the regression coefficient, and the E is the error term, or some books call it mu or E or whatever. This is the error term. And here is the difference between the mathematics and the econometrics, because in mathematics we don't deal about this error term, we only deal about this function y is equal to beta 0 plus beta 1 x. We only deal about this function, not this is the error term. But when we are studying econometrics, we need to calculate this error term. This is the difference between them, and it's known as a random error term. And the another name for this dependent variable is response variable. And now let's define this, the equation 1, and this is the equation 2. Why? This is the mean of distribution, and we'll see some of the properties of a linear regression model. For convenient to view this regressor x, these are the regressor or independent variable x as controlled by the data analyst and the measure with a negligible error. And what is the error term is very negligible or very tiny with this the response variable y. And since both are also it's a random variable. And now what we'd like to interest in the probability distribution of y at each possible value for x, and the mean of the distribution is like this: expected value of y is given by x is equal to beta 0 plus beta 1 x. And let's define this equation number 2. And why it's very important? Because the mean of y is a linear function of x. Okay, this y, and actually this comes from like this is same from this function, and the mean of y is a linear function of x, although the variance of y does not depend on the value of x. This is very important. The mean value of y is linear function of x, because this power is 1 linear function of x, and the variance of y means the deviation of the y does not depend on the value of x. The deviation of y doesn't depend on the value of x. And because the error term is uncorrelated, because this very important, error term is uncorrelated, this error term is not related to this regressor, the regressor error term is not depend on the response error term. This also are uncorrelated. And the most important things, this parameter beta 0 and beta 1, sometimes we call the regression coefficient. This beta 0 and beta 1 is our regression coefficient, and the slope, and actually this is the most fundamental key for our explanation regression analysis. The slope beta 0 is the change in the mean of the distribution of y produced by a unit change in x. This is very important. Suppose this regressor increases by 10 unit, and how much the dependent variable or response variable will increase. Or suppose the regressor variables decrease by 5 unit, and how much y will be decrease or increase. This is the one kind of relationship, and later we'll define why we call it linear regression and why it's not multiple regression. We will talk the last part of our video. Okay, and this is our main aim because we'd like to test hypothesis. Suppose we will take that education is related to wage. Higher educated person will get more wage, and the lower educated person, the illiterate person, will get lower wage, and we will test hypothesis for this parameter. So this is very important. And the mean value of the distribution of y produced by unit change in x, since x is the mean value is 0, this mean distribution is 0, and the variance is equal to sigma square. This is the one of the most fundamental two properties. And first we have define what is the simple linear regression model and why we call this linear. Actually a model with a single regressor x, because here is only our regression is x, only one, so we call simple linear regression function, and it may be xi, x1, x2, x3, xk, lots of multiple linear regression function. But here our inner model is simple regression x, and the relationship between response y and x is a straight line. Later we'll see when we'll draw graph for this, we'll get the simple linear exact straight line. For this reason we say a model with a single regressor x, this is our only single regressor x, and the relationship between the response y variable, and for this reason we call this the simple linear regression model. And the important things again, this is the two unknown, this parameter beta 1 and beta 0 is our unknown constant and is the error term, and this error term is very negligible, and this kind of relationship we'd like to find out in our variable. And in a later variable we will see how we can expand simple linear regression function to multiple linear regression function, and what are the different assumption for this linear regression function, so the OLS and lots of things.